Is our universe really the whole, or is it just a brief part of a cycle of worlds that will never end? Well, Roger Penrose, a British scientist who won the Nobel Prize, knows the answer to this question. More than that, he is sure that the universe is always being destroyed and then being born again. These points may be where the supermassive black holes from an earlier universe evaporated. Around 100 years ago, what we now know as basic astronomy was, at best, a strange idea. In fact, until the middle of the 20th century, most scientists thought that the world was a thing that would last forever and never change. In the cosmos, stars could come and go, planets could crash into each other, and civilizations could grow and fall apart, but all of this would happen over a very big area and over a very long time. At the time, that's what people thought. The world always looks the same on the surface. Still, scientists eventually figured out that galaxies far away are moving away from Earth, and the speed of this galactic escape is even getting faster as the distance between the galaxies grows. After a lot of thorough follow-up studies, scientists finally found out why these galaxies were moving in such strange ways. It's not really the galaxies that are moving through space, it's just the way things are set up. No, it's space itself that's always getting bigger. That is, the experts finally came to terms with the fact that the universe is growing and gave up on the idea of a rigid, unchanging universe. However, it wasn't until the 1960s that scientists understood this process of expansion leads to an extreme original singularity. It was this singularity that caused the universe to form 13.8 billion years ago during the Big Bang. Perhaps not since the heliocentric viewpoint became popular had there been such a big change in astronomy. That is, even though we now know that the Sun is not the center of the universe, it is the center of our own system. But as is so often the case, the groundbreaking insight was tied to some deep questions. If the world really did start with the Big Bang, then what came before? What did space look like before it grew bigger? How long did it stay in this primitive state? We still don't have clear answers to these difficult questions, just like Roger Penrose did with the endless cycle of the universe. These questions are as old as the Big Bang theory itself. Even when experts think about it in a theoretical way, they don't really agree on the opposite. A lot of people who study astronomy have long since split into two groups about this problem. Stephen Hawking, for example, thought that asking what was there before the Big Bang was like asking what is north of the North Pole, since time started with the Big Bang. Before that, there couldn't have been anything. On the other hand, Roger Penrose's ideas are different. The Brit had worked with Hawking before as a theoretical physicist in the 1960s. Together with Hawking, he made a groundbreaking discovery about singularities and black holes. The Nobel Prize in Physics was given to Penrose again in 2020, at least with half of it. He won half of the prize for discovering that the formation of black holes is a robust prediction of general relativity. Reinhard Genzel and Andrea Ghez won the other half for finding a supermassive black hole at the center of the Milky Way. But if we put aside the Nobel Prize and focus on the subject at hand, we can see that the experienced scientists first looked at the question of how the universe began and where it is going from a philosophical point of view. Penrose had to first say what exactly is the universe and what exactly is not the universe. At the end of the day, the British scientists came to the following conclusions: the world is mostly made up of moving things, which means there must be at least two solid or moving things whose distance changes over time. It is not possible to measure a conditional space, though, if there are no or only one of these things. To put it another way, we can't say if space is endless or if it has been squeezed into a very small volume, like in a singularity. Things like speed and time have no meaning at all in this situation. Penrose says that it is likely that the universe will one day return to a state so extreme that it can explode into a new life. This model says that the universe will keep growing until all the matter has broken down and turned into light. This strange world, where nothing is connected to anything else in time or space, finally makes room for a new Big Bang. For the record, Penrose says this is not a one-time event in the history of astronomy, but rather a trend that happens over and over again. As was said at the beginning, the Briton is sure that the universe is made up of cycles of death and rebirth. If, on the other hand, the endless resurrection of the universe is real, shouldn't there be some proof of it? In fact, Penrose says it does exist, and we have already found it. Do Hawking points come from a different universe? Penrose, Daniel and Christoph Meissner, and Paul Narowski have found an interesting signal in the cosmic microwave background CMB that should help us figure out what the universe is really like. The readings from both the Planck and WMAP satellites show a lot of round spots that are about the size of the full moon. What do these spots have to do with a universe that goes through cycles, though? Also, why did scientists miss them for so long? In the cosmic microwave background radiation, or CMB, is a leftover from the early days of the universe. It was made about 380,000 years after the Big Bang during the recombination epoch. In fact, the background radiation still covers the whole universe, since it was already expected by the Standard Model. Finding it is seen as the best proof of the Big Bang theory. Following this line of thought, Penrose now thinks that finding the so-called Hawking points is the best proof for the cycle theory. In the end, the spots we talked about earlier match to multiples of the average changes in the CMB temperature. These strange things were found in the same places by both Planck and WMAP. They were not noticed until now because it was thought that cosmological inflation would have erased them entirely. A short explanation: cosmological inflation is the name for the period of very fast growth of the universe right after the Big Bang. Even though the cosmic growth spurt was very short, a fraction of a second, it's thought to have made it bigger by at least 10 to the power of 26. To use a more concrete example, the area that is now the visible universe had a diameter that was much smaller than a proton at first, but all of a sudden it grew to 10 cm. These stages of inflation are also known as cycle models, but they place them in the time before the Big Bang, which is a small but important difference. To put it another way, inflation comes from the far future of epoch of the world growing at an exponential rate. As was already said, the cyclic model includes an endless number of these eons, and each one has its own Big Bang that marks the continuation or exponentially growing far future of the one before it. It's interesting that the change from eon to eon is okay from both a logical and a physical point of view. As it turns out, the cold, far-off future with low density is condensed in a way that matches the growth of the hot, dense Big Bang in the next eon. One thing is different, though on paper, giant black holes don't seem to adjust so well to the next eon. On the very last day of the universe, they would have eaten up almost all of the galaxy groups nearby before turning into Hawking radiation and disappearing. But because of something called the conformal squeeze, all of the energy that is released goes into the next eon as a single Hawking point. The process makes photons that scatter in an expanding area, but these photons are not released until they finally show up in the microwave background radiation of the next eon. But to us, the area in question would again look like a disk with a width equal to the full moon. It looks like we can see this effect in the CMB sky. That is, the strange spots might show where the Hawking points of the black holes from the old universe are found in the background radiation. Not all experts agree, though, on whether or not we are really looking at a real cosmic obituary. Roger Penrose stays cool, though. The British man still strongly believes in the idea of a circular universe and tells those who disagree with him that black holes were once thought to be nothing more than a mathematical trick. We are all aware that we are smarter now, though. And who knows which of the ideas that are still not widely accepted today will one day be accepted by astronomers as well.